Hello, everybody. Hello. Thank you for joining us today. This webcast is powered by Yole Development and will deal with Liion battery recycling. My name is Faisal Kamasi, and I'm a global super sales and coordination manager for Yole Development. To shortly introduce you the company, Yole Development is part of the Yole group of companies which provide marketing, technology, and strategy consulting, media, in addition to corporate finance services. We support industrial companies, investors, and R&D organizations worldwide to help them understand markets and follows technology trends to develop their business. Before we start the webcast, let me give you some basic information on this online event. You have the possibility to submit questions during all the webcasts. You can use the Ask a Question window at the bottom of the screen. We will answer as many questions today as we can, and for the remaining one, we will follow up with you via email. Concerning the materials, please note that the presentations are already available and they can be downloaded from the resource section at the platform. Furthermore, you will receive tomorrow an email with the link to the recorded webcast session. So let's start the webcast. I am pleased to welcome Shalu Agarwal, Market and Technology Analyst at Yole and Specialist of the Power Electronic and Materials. Shalu, the floor is yours.
Yeah, thank you, Faisal. Thank you for the nice introduction. Hi, everybody. Thank you for joining this webinar. So today in our webinar, we are going to discuss about lithium-ion battery recycling, whether it's a burden or a new business opportunity. So in this webinar, we will discuss about the lithium-ion battery recycling, its technology trend, supply chain, market figures, and many more. But before going to discuss about lithium-ion battery recycling, I want to discuss a bit about lithium-ion batteries. So lithium-ion batteries are rechargeable batteries which have high energy density and which have low self-discharge property. In lithium-ion batteries, the lithium ion moves from one electrode to another during the charging and discharging. The anode of battery, lithium-ion battery, the anode is generally made up of graphite, but the cathode, there are various kinds of cathode components and there are various kinds of materials involved in this cathode components. If we, for example, there are lithium-ion batteries which have cathode made up of NCM, like a nickel, cobalt, manganese. We call it NCM lithium-ion battery, or we have LFP, where the cathode material is made up of lithium fluoride phosphate, and many more. So if we see the lithium-ion batteries, overall structure or the components, the most expensive part of lithium-ion batteries is cathode component. Cathode component, it contains many valuable materials which are not easily available everywhere, and the cost is very high. For example, cobalt. Cobalt is not easily available everywhere. They have the mines which are concentrated in few areas, like the main source of cobalt is the country called Republic of Congo. So most of the mines are located in Republic of Congo. So these materials which is used in the cathode components are not easily available and the cost is also very high. Now let's discuss about the application area of lithium-ion batteries. Lithium-ion batteries finds many applications. The most common and traditional application area of lithium-ion batteries are consumer goods. For example, our laptops, phone, tablets, they are all powered by lithium-ion batteries. The second application area of lithium-ion batteries are clean energy generation and storage. For example, wind and photovoltaic. Currently, the most important area of lithium-ion batteries are e-mobility. As in every country, the government is trying to reduce the carbon dioxide emissions. So that is why the demand for clean transportation is increasing. If we talk about clean transportation, then we need to talk about electric vehicles. So all the electric vehicles which either emit less carbon dioxide, or in full electric vehicles, they don't emit carbon dioxide at all are powered by lithium-ion batteries. A lithium-ion batteries has other applications area also, like militaries, aerospace, uh, medical, etc. As I told you that lithium-ion battery is the most important application area of lithium-ion battery. Currently is electric mobility. So if we talk about electric mobility, it's not only car, but we are covering the other segments of electric mobility. That is electric buses, electric trucks, two-wheelers, and in some countries like India, there are many electric three-wheelers also. So in our report or in our website webcast, we are not involving only the car, but we are covering other segments also. If we talk about lithium-ion batteries, they have many applications area, but the growing lithium-ion battery applications have positive impact on technology advancement and to reduce the carbon dioxide emission. But they also raise another issue, that is the waste. The batteries which once powered our consumer goods or electric vehicles, when they reach to the end of life, they are of no use. They are just a burden on the earth. And as the lithium-ion battery market is growing, so the burden or this e-waste, the quantity of this e-waste is also growing. But it doesn't mean that all the end-of-life batteries are going to landfill and they are increasing the waste. There are the lithium-ion battery recycling market is equally growing as the lithium-ion battery application area is growing. So what is the importance of recycling? Only because they reduce the waste which is generated by the end of life lithium-ion batteries? No, this is one of the area that if we talk about the environmental aspect, yes, if the recycling business will increase, the more and more end-of-life batteries will go for recycling, and it will reduce the waste, and the less and less batteries will go to the landfill. But if we talk about economical aspects also, recycling of lithium-ion batteries is very important. As I told you, the most important part of lithium-ion batteries is cathode components. And the cathode components, there are many expensive and valuable raw materials are involved. And they are not available everywhere. So for example, let's take example of cobalt. The main mines of cobalt is located in Republic of Congo. What if there is some geopolitical issues and it will be difficult to get the cobalt for cell manufacturing? If the recycling business will grow, then it will reduce the risk associated with the geopolitical issues, and then we can get the more raw materials for cell manufacturing. The mines cannot be no if there is no mines in everywhere, but it's easy to establish a recycling facilities in many countries or to increase the capacity. So if there will be more and more capacity of recycling companies, or there will be more and more recycling companies, the more batteries will go for recycling, and the materials which will recovered from this recycling can go for cell manufacturing. It will again reduce the cost of cells, and finally the consumer like us will get the benefit, because if the cost of battery will reduce, the cost of final product like our consumer goods or electric vehicles will also reduce. Here I am trying to show the process flow of recycling. Once the lithium-ion batteries are unfit for the use, or when they are dead or reach to the end of life, the first step for recycling is the collection and transportation of those end-of-life batteries. The collection, packaging, and transportation of lithium-ion batteries is not easy, and all the transportation companies or packaging solutions, they cannot do the packaging and transportation of lithium-ion batteries. because lithium-ion batteries, it contains many hazardous materials. So if any transportation company or packaging solution company, they want to pack or transport these lithium-ion batteries, they have to follow many rules and regulations. Once this end of life or that batteries reach to the recycling site, the second step is discharging of that end of life batteries. Most of the end of life batteries are already discharged, but if the batteries are not charged, they are not discharged, then it's very important to discharge these charged lithium-ion batteries. After that, this dismantling. In case of electric vehicle, the dismantling is a very complicated step, and we will discuss more about this dismantling in our next slide. After dismantling, when there will be a lot of lithium batteries, then they go for mechanical recycling. And after the mechanical recycling, we get the black mass. This black mass is the mixture of the components, the materials present in cathode component, for example, cobalt, lithium, manganese, nickel. So the black mass, this is a mixture of all these materials. After getting this black mass go for metallurgical process, and with the help of metallurgical process, we again get the clean raw materials. This is a general process flow, but it doesn't mean that all recyclers follow all these steps. Many recyclers have their own recycling process, and many recyclers, they skip one or two steps of these given steps. But this is just a process, general process flow. As I told you in previous slide, that dismantling of lithium-ion batteries pack, which we received from end-of-life electric vehicles, it's a very complicated step. Currently, battery pack assembly is optimized and efficient process, but dismantling is again still not optimized, because there are many various kind of battery pack size, shapes, formats. There are various kind of interconnections. There are various kind of cooling system. So there is not one standard battery pack. All the OEMs, they have their different designs, different chemistries, different kind of sizes of battery packs. So it's very difficult to dismantle these the various kind of battery packs. Currently, the battery pack dismantling is done by manually. But with manual disassembly process, there are many issues. First important issues in those countries where labor cost is very high. So if all the dismantling process is done by manual or human, it will increase the cost of overall lithium-ion battery recycling business. Again, there is, because in lithium-ion batteries, there are many hazardous materials. So it is the human dismantling process is again associated with many safety issues. And there is many chances of human errors. So that is why the automated disassembly method is much better than this human disassembly method. But again, because there is no standard size shape of battery packs, the fully automated disassembly step, we don't think it is feasible, and it's not going to come in coming years. But now trend is moving towards the semi-automation. Semi-automation means the dismantling of electric vehicle battery packs can be done by smart robots and machine. And so in semi-automation, humans and smart robots can work together. This is the next step of recycling. Once the battery packs are disassembled, then they go for mechanical treatment. And as we have already discussed, we get the black mass. This black mass go for metallurgical process. There are two types of metallurgical process. First is pyrometallurgy, and the second one is hydrometallurgy process. From pyrometallurgy process, we get the alloy and the slag, and the finally hydrometallurgical process is for the purification of this purification and getting the pure raw materials from this alloy mixture. So all the process flow which we have discussed in the previous slides, all these steps are not easy, and there are many challenges associated with each and every step. And if we talk about electric vehicles and end-of-life batteries, the challenges are double. The challenges start from the first step, that is removing these big battery packs from the electric vehicles, which needs time and training, and it is again it's the additional cost. Second is transportation of electric vehicle batteries. As in every country, there is not recycling facilities are available. So when the batteries reach to the end of life, they need to be transported from those areas where the recycling facilities is available. The country where there is no recycling companies, they have to send these end-of-life batteries to another country, which is again very challenging and very expensive. Third is disassembly. Disassembly, as we have already discussed, as because there is no standard size, shape of battery packs, so disassembly of these battery packs is again challenging. And the recycling process is again itself a challenge, because all the battery packs, they have different kind of chemistry. And for different kind of chemistry, there is different chemical processes are needed to purify those raw materials, which is there in the black mass. Here we are, sorry. Now let's discuss a bit about supply chain. So this is the overall supply chain of lithium-ion battery recycling. As lithium-ion battery recycling business is growing, and the main reason is electric vehicles, the opportunities of all the companies involved in many different positions of this recycling supply chain is also increasing. It starts with the refining of raw materials to the end-of-life batteries, transportation, collection, followed by recycling. Like as I told you that lithium-ion battery packs are very big and the transportation is not easy. So the companies which have a safe transportation mode and which companies which follow all the rules and regulations, they can get tremendous business in this recycling market, because in coming years, many end-of-life electric vehicle batteries are coming for recycling. Same with recycling companies, as there will be many end-of-life batteries in coming years. If the recycling companies, if they can increase their capacity, or they can establish a new recycling companies in those countries where cell manufacturing companies are available, or there are many electric vehicles are used. If they have their recycling plant in those countries, it gives a tremendous business to those recycling companies. And then many recycling companies, they don't follow all these steps. Hello?
Hello? We can see the screen.
Okay, so
yes.
Okay. So in the supply chain of electric vehicles end-of-life batteries, there is tremendous business of all the steps of the supply chain. Here we try to show some recycling companies and the geographical overview. But these are not all the companies, but this is non-exhaustive list. There are many more. But from this slide, we can see that most of the recycling companies are located in Europe and China. There are many other recycling companies in Japan also. Currently, recycling business is increasing in India also. We can see many companies in America, but most of the recycling companies are located either in China and Europe. Here we can see the supply chain of recycling. And generally, the supply chain, one position is linked with another position, but the supply chain of lithium-ion battery recycling, although one position, the companies involved in one positions are connected with another position, but they are also directly linked with recycling business from recycling companies. For example, if you see the cathode manufacturers, they make cathode and they send their cathode to the cell manufacturers, but they have direct partnership with recycling companies. so that they can send the scrap which generate during the manufacturing of cathode. And once they send the scrap to the recycling companies, in return, they get the pure raw materials which can be used for the cathode manufacturing. Similarly, with cell manufacturing, they have direct partnership with the recycling companies so that they can send the scrap we generate during the cell manufacturing, and in return, they get the pure raw materials. If you talk about battery pack manufacturers, they don't need raw materials for themselves because they don't make cells, but they have the partnership so that they can send their scrap generate during the pack manufacturing, and in return, they can get the raw materials for their cell supplier, not for themselves. Similarly, with system integrator, or for example, OEMs or car makers, they send their end-of-life batteries to the battery recycling companies, and in return, they get the raw materials for their cell suppliers. So there is a various kind of partnership between all the steps of supply chain to the recycling companies to secure the raw materials either for themselves or for their cell suppliers. Now here we can see that because of electric vehicle market, there is the recycling movement. There are many recycling movements, and the recycling business is also reshaping. Here we can see there is more and more partnership between the car makers as well as between car makers and recycling companies, so that they can send their end-of-life batteries to the recyclers. And because there are in coming years, there will be lots of end-of-life batteries, but currently the recycler companies have limited capacity. So to get the security, there are more and more partnership between OEMs and recycling companies. Similarly, there is more and more partnership between the cell makers and the recycling companies so that they can send their scrap manufactured during the cell manufacturing, as well as they can send their end-of-life batteries to the recycler. And in future, we will see the more and more partnership between recyclers, OEMs, and cell makers. If we talk about end-of-life batteries, electric vehicle batteries, so the batteries which is unfit for electric vehicles, they still contain 70 to 80% of their initial capacity, which is a huge capacity. So those batteries which are unfit for electric vehicles, they have two options. Either they can go for recycling and get the raw materials, but the batteries have 70 to 80%. So another option is that they can go for second life. And after finishing second life, they can go for recycling. So these two options are in parallel, and the electric vehicle end-of-life batteries can go either for recycling directly, or they can again enjoy the second life. And after finishing their second life, they can go for recycling. Now let's talk about the market figure. In our report, we have included three source of waste in our forecast model. First is the scrap generates during the manufacturing of cells. If we talk about consumer goods, the main source of battery waste will be the end-of-life batteries. But the scrap which generate during the manufacturing cannot be ignored. In case of e-mobility, the scrap generate during the cell manufacturing, they have a huge portion in the waste generate during the electric vehicle end of life, and the waste generate during the electric vehicles. And the third, we are also including the end of second life batteries. Although right now there are not end of second life batteries available for recycling, because the electric vehicle market is new, and most of the electric vehicle batteries still enjoying their first life. So there is almost nothing in second life batteries. But still in our market forecast model, we have included the three source of waste. One is the scrap, second is end of first life, and third is end of second life. Here we try to show the number of waste which generate last year, and we are trying to show the number of waste generated in coming 5 years. Here you can see the waste generated because of lithium-ion batteries. It is so high. In 2019, there was around 200,000 tons of waste generated from these lithium-ion batteries. And this waste will increase and reach up to 700,000 tons by 2025. Then we try to calculate the value of raw materials present in this cathode of these waste materials. And then we found that in last year, the batteries which were waste lithium-ion batteries, the total materials, the value of total raw materials was around $900 million. And in 2025, it will reach around $2 billion. It's a big value. But sadly, all these waste lithium-ion batteries, they don't go for recycling. Most of the batteries will go to landfill, and very small amount of batteries will go to the recycling. So here is the total number of batteries which will go for recycling. So if we can see that in we can see that in 2019, around it's less than 100,000 tons of batteries are going for recycling, and most of the batteries are going to landfills. By 2025, around 450,000 tons of batteries will go for recycling. And then we calculated the value of raw materials associated in those waste lithium-ion batteries, which will go for recycling. And then we found that in 2019, around $300 million, the value of the raw materials present in these waste batteries, which went for recycling, was around $300 million. And by 2025, around $1 million the amount of involved in these batteries, which will go for recycling, will be around $1 billion. It's again very big value, but if more and more batteries will go for recycling, the more and more value we will get. Here we try to show the sheer evolution of different applications. In our forecast model, we took 4 applications: e-mobility, consumer goods, stationary storage, and other applications. Here in 2019, you can see that the contribution or share of consumer goods and electric vehicles are almost similar. But with time in coming years, the share of consumer goods will go down and the share of electric vehicles will grow significantly, and it will become the #1 application area for lithium-ion battery recycling market. So why, even though there are many waste batteries, but not all the batteries are going for recycling. So what are the main drivers so that more and more batteries can go for recycling? We have tried to gather the more and more drivers to increase the lithium-ion battery recycling business. So first thing, according to me, the first thing should be the public awareness. The public, they don't care about recycling of batteries. They don't care. Once the batteries reach to the end of life, their mobile battery reach to the end of life, they just put in the trash. We don't care about recycling. So the most important thing, if you want to increase the recycling business, the most important thing is the public awareness. We should start thinking about recycling of batteries. If the public is aware, more and more batteries will go for recycling. Second is, even though there will be a lots of batteries going for recycling, but currently the recyclers, they have limited capacity. So if there will be more and more batteries going for recycling, the recyclers should increase the capacity. Capacity increasement is not so easy. It needs a huge investment and many strategies. But still, if there will be the more capacity, of course, the more and more batteries will go for recycling. The third is government regulations. In case of electric vehicles, the OEMs or car makers are responsible for taking care of recycling of their end-of-life batteries. But in case of consumer goods, nobody is responsible. So government should put more and more regulations, rules, and penalties so that everybody can think about recycling, and so that more and more batteries can go for recycling. And fourth, and the most important market strategy for lithium-ion batteries is the value. If the value of recovered materials is high, the more and more batteries will go for recycling, and recyclers will also motivate for the recycling. But if any case, the value of these raw materials will go down, there may be many reasons. For example, if the chemistry is very complicated, or if nowadays, if we see that in our new batteries, there is less cobalt content, and the cobalt is the most expensive material of cathode components. So if there will be less cobalt content, it will again reduce the motivation to recycle these batteries. Third is maybe the cost of all raw materials present in this cathode, like cost of cobalt, nickel, if it goes down, then again it will reduce the motivation for recyclers to recycle these batteries, where every step has a challenge, starting from dismantling to recycling process. They have to deal with many challenges, and finally, if the value of this recovered material is low, it will reduce the motivation. And if there is value of these raw materials will reduce, then there will be only one and main way so that batteries can go for recycling. It will be the government's rules and regulations. If there will be strong rules and regulation, even though there is motivation or not, the recyclers must recycle the lithium-ion batteries, and the consumer goods and electric vehicles, we have to send our batteries for recycling. So in any case, if government put more and more regulations, then there will be more and more batteries will go for recycling. Now I have reached to the conclusion, and I would say that in consumer goods, the most of the batteries are still going to landfill, and sadly, only few amount of batteries are going for recycling. In case of electric vehicles, most of the batteries will go for recycling, because in electric vehicles, the car makers are responsible for the taking care of recycling of their end-of-life batteries. So I would say that although the battery recycling market is growing, but the potential market could be much, much higher than the current market. It just needs the public awareness, government regulations, and there will be more battery market in the coming years. But just public awareness cannot increase the recycling business. For that, recycler companies should increase the capacity, which need high investment and correct strategies. So the companies, recycling companies, which are maybe small today or newcomers, if they are able to put more investment and they have the right strategy, in future, they can see their shares in this recycling market will grow. And today's big companies, if it depends on their strategy and investment, they can see the decrease in market share in coming years. All depends on the approach of their recycling. Because of electric vehicles, we think that there will be more and more partnership between car makers, recyclers, cell manufacturers, and stationary storage companies. So in future, we will see the more and more partnership. We will see more and more joint ventures, more and more merger and acquisition. And the main reason is the electric vehicles end-of-life batteries. I think that 30 minutes webinar was not sufficient to discuss many things about recycling, but we have done the thorough investigation, and our recycling report is already published. You can have a look and on the flyer of this lithium-ion battery recycling report. Currently, we are not only working on lithium-ion battery recycling, but we are covering other areas of lithium-ion batteries. For example, we are covering the area about lithium-ion batteries. We are covering the area related to electric vehicles, battery packs. We are also covering the area not only about lithium-ion batteries, but batteries beyond lithium-ion batteries. So thank you so much for your attention, and I'm here to answer your questions.
Thank you. Thank you very much, Shalou. This is a very interesting presentation, and 30 minutes is not enough, but we are now going to wrap up with Q&A session. We will answer as many questions today as we can, and we will follow up via email for the remaining one. So let's start. We have a lot of questions. So first question, Shalou, what do you think about the trends regarding EV batteries recycling or second life application?
Recycling and second life application. Yes, actually, as we discussed already, the end-of-life batteries, they still have 70 to 80% of initial capacity. So actually, they have two options. They can go either for recycling or they can go for second life. The battery which have 70 to 80% of initial capacity, according to me, they deserve the second life. And we think that in future, the more and more batteries will go for second life before going to recycling. But this is the ideal condition. No, a battery which is in electric vehicles, now it is unfit for electric vehicles. And inside there is 70 to 80% capacity. They are going for second life and then they are going for recycling. So this should be the ideal condition. But there are many issues associated with second life applications. For example, when the battery pack of electric vehicle, which is very huge and dismantling is very difficult. If the battery pack is going for second life applications, first they need to disassemble. A disassembly, which we have already discussed, is very complicated task. Then we have to check all the health of all the batteries because these are not new batteries, they are second-hand batteries. So they have to check the health of all the batteries. And then again, they have to make assembly and they need to make the modules according to the requirement of second life. All these things are not so easy. The dismantling of previous battery pack, then checking the health of all the batteries, and again making the new battery pack depending on the requirement of new application. It's very complicated. Secondly, for OEMs or the car manufacturers, they are responsible for the recycling of their end-of-life batteries. So first they have to monitor their batteries, end-of-life batteries. They have to take care of those batteries for first 8 years. Then the batteries will go for second life and they will again spend 10 or 12 years in second life. So the total life of these batteries would be 8 or 10 in first life and then again 10 years in second life, around 20 years. Then OEM have to monitor those batteries for 20 years. This is again very complicated and not very difficult for OEMs. So they are also not very motivated for second life applications. So ideal condition, the more and more batteries should go for second life. But currently, there are not many end-of-life batteries available on markets. So most of the batteries are still enjoying their first life. So the real trend we have to monitor in coming years. But yes, there will be more and more batteries will go for second life.
Thank you, Shalou. Second question. This is also a question I would have. Many people think that electric vehicles are not ecologically friendly, as it's very difficult to recycling their end-of-life battery. What do you think? What steps should be taken so that more electric vehicle battery can be recycled?
For me, I would say that the first thing, as we have discussed, that the recycling of these big battery packs is very complicated, and the challenges start from the first step. The very complicated part is dismantling of these battery packs. They are easy to assemble, but it's very difficult to dismantling of these battery packs. So first thing, I think when the battery pack manufacturers make the battery packs or they discuss the design of battery packs with OEMs, they should also think about dismantling. The dismantling step should be easier, not so complicated. If the dismantling step will be easier, then it will also increase the recycling market for electric vehicles. Second, the capacity of recycling companies, they should think about increasing capacity. Right now, most of the recycling companies are trying to increase the capacity, but currently there are not so many electric end-of-life batteries are available. So many recycling companies, they are also not very motivated. But if they increase their capacity, there will be again more and more batteries will go for recycling. And the most important is the government regulations. For electric vehicles, if you talk about cars or trucks, the OEMs are responsible. But for small batteries pack, for example, for two-wheelers or in three-wheelers, still nobody is responsible. And so the government should put more regulations and rules so that somebody should be responsible for the recycling of these end-of-life batteries. If somebody will be responsible, then of course more and more batteries will go for recycling.
Okay, thank you. Another question, do you think that recycling can be the secondary source of raw materials needed for battery manufacturing?
I would say yes, it can be the secondary source. As we have discussed earlier, that in batteries, the most expensive or valuable part is cathode, and the materials which is present in cathodes is not easily available in every country. For example, let's take the example of cobalt. The cobalt is mainly concentrated in Republic of Congo. What if there is some political issues, some war, and like right now, the COVID-19, there is a limited transportation. So in that case, sometimes it's not easy to get the raw materials for the manufacturing of cells. If there will be more recycling companies, and there will be recycling companies in that country where there is many cell manufacturing companies. So, and there will be more recycling of batteries, then the raw materials, there will be more recovered raw materials which can be from recycling. And of course, it will become the secondary source. It can never become the primary source because the recycling rate is very low. But still, in emergency, or there will be a smooth, supply of raw materials. So I would say yes, not primary, but of course, it can become the secondary source of raw materials for cell manufacturing.
Okay, Shalou, thank you very much. We have still other questions, but the webcast is now over. So we will answer the other question by email. So you will receive soon an email with the link to the recorded session. Also, feel free to share the presentation with your colleagues. And please let me remind you that you can find all our reports on our website, www.i-ifmicronews.com. And do not hesitate to contact us if you have additional questions. You can find our contact details on the last slides of the presentation. Thank you for joining. Thank you, Shalou, and have a good day. Bye-bye.
Bye-bye. Thank you so much. Thank you. Thank you, everyone.